All right, hello, this is Mike Adams, the Health Ranger here, the founder of foodrising.org, the editor of naturalnews.com, executive director of the Consumer Wellness Center nonprofit. And I'm here to show you some of what goes on behind the scenes when we are building 3D printable objects. So to do that, I have a blank screen here in Solidworks, which is the software that I use. And I just want to show you a few simple things. Let's make sure we've got the grid snap on. Yep, this all looks good. So if we wanted to build, let's say, an adapter to connect a garden hose to a mason jar, that's what I'm going to demonstrate here. I'm going to show you how to do that. We go to our top plane, and we know that the mason jar, I'm going to use rough dimensions for this, although we could use exact dimensions, but oops. I'm going to use a diameter here of, I believe, 24 is about what we want for a mason jar. Actually, I'm going to check that. Oh, no, that's wrong. Looks like it's about 44. So we're going to make a 44 millimeter circle. That's the radius is 44. And then we're going to make another circle that is, I don't know, let's call it 48. So we have right here, we have a thin structure, and then I'm going to extrude that structure on the z-axis to about 24 millimeters. And so this gives us roughly the shape of the lid that's going to screw on to the mason jar. Now what we have to do is we have to build threads for this, and this is where things start to get kind of tricky. So we're going to go back to the top plane. We're going to make a thread circle, which will also be roughly the same diameter. I'm going to make that 44, I believe. Yeah, that's what we chose. And we'll label this. This is our thread circle. You can't see some of the menu commands off screen, but those really aren't necessary. Now I'm going to create a helix, and I'm going to define the pitch of this helix. I happen to know that a 6 millimeter pitch is what is necessary for a thread helix of a mason jar, because I've measured that out. So I'm going to go ahead and create this 6 millimeter pitch. As you can see right here, it says 6 millimeters, and I can reduce the revolutions down to 5 or 4, whatever I need. There, 4 looks, well, maybe 5. 4 looks fine, actually. And I'm going to create that helix. Now, in order to make the actual threads, we need to build a triangle that is the shape of the threads. So we're going to go down here, and we're going to create a triangle that is roughly the shape of the threads. And I happen to know that for a let's see, for a mason jar, the threads are about 3 millimeters in diameter, which means we want to go up about 1.5, and we want to, I'll adjust these later. We want to go out only about 1.8. Oops. Wrong. Mine is 42.2. That gives us a 1.8 on that. And our Y on the top hole is going to be, actually, we're just going to go about 3.5 here. And we're going to do this at about 0.5. And we may go back and fine tune this later, but we're going to call this is the mason jar thread. Now then, we're going to extrude or actually sweep this thread shape across this helix. And when we do that, we're adding on the threads, as you can see. now we have the threads inside the jar lid. Now you'll notice we've got some threads that are hanging out below, too far below. So the easy way to deal with that is you're going to create a new plane here by dragging from the parallel top plane. And let's say I want a 4mm plane there. And then what I'm going to do is I'm going to move our original thread circle. Come on. Waiting for the software here. I'm going to move the thread circle to that plane. There. And then I'm going to actually edit the thread triangle itself, and I'm going to change the Y position of that to be up 4. And then once we do that, you'll see that we no longer have threads below. We've got some threads sticking out the top. But what we can do on that, there's a number of ways to deal with that. We can, for example, we can reduce the revolutions of the thread itself to 3.5, and you notice it's now right inside the object. So what we have here so far is a cylinder that will screw onto the top of a mason jar. Now, suppose we want to now have something that, well, we were building what? A garden hose adapter to a mason jar. So what we want to do at this point is we want to take a front plane sketch, and we're going to build a funnel, a cone that will work with the garden hose. Now we know that the garden hose diameter is about 12.2 for the female garden hose receiving threads. So we're going to put something here. We're going to go out here and we're going to do, I don't know if you like this angle or not, but we'll call it a good angle. And we're going to connect these along the bottom here, so we have a triangle. And then finally we're going to sketch a center line in this sketch here. And then we're going to take this triangle and we're going to do, we're going to do a revolved extrusion of the triangle around the center line. So now what we have here is we've just built a solid cone on top of the threads underneath by, again, rotating this triangle all the way around this center line, which is, it's called a revolved extrusion base, and that's a real nice technique. Now, but let's say, well, we don't want this thing to be totally solid, as right now it's completely solid. Instead, let's say we just wanted like a thin structure and not an entirely solid, because that's going to use a lot of filament if we do it that way. So what we can do is we can select this entire shape, and we can do a linear sketch pattern. Oh, I'm sorry, I don't want a pattern. I want an offset entity. And we're going to do an inward offset of, let's say, 2 millimeters. Or maybe make it 3. I want it to be a little bit stronger, a little bit more watertight. So now we have a hollow shape that we're going to extrude around the circle. Now, the way you can see it is you can change your view to be kind of a see-through view. So now, as you can see, we have this is a solid wall, but this is an air gap that goes all the way around. And what we have in the middle here is a location where we can screw in a garden hose as soon as we build the threads. So that's our next step. And to do that, we're going to go to the top plane. We're going to create another another plane right here. We're going to start carving some threads. We'll call that 61.5. And we're going to do a similar thing that we did before with the threads below. So I'm going to start out with a circle here. And by the way, when you're doing this, you're always dealing with geometries. I mean, you need to have a good solid understanding of geometry, good spatial orientation, the ability to visualize 3D space so that you know what you're doing. All right, so I have a circle here that's 12.2 millimeters in diameter. And from that circle, I'm going to do a helix again. But in this case, I'm going to reverse the helix to go downward. I'm going to change the pitch to 2.2 millimeters, which is that's the pitch of a garden hose. And I'm going to add revolutions, give it about 6 revolutions. So that's a helix that's going down into the object. Now all I have to do is build the cut threads to cut the threads into the shape. And I'm just going to cut it up here. We're going to be cutting into the walls of this shape because we're cutting a female thread pattern into this. So, well, actually, where do I want to start? I guess we'll start here. Oops, give me a line. Come on. Okay. Well, you know what? I'm probably gonna manually edit these anyway, so I'm just gonna do a rough sketch on them right now. All right, so I happen to know the numbers on this because I've done this so many times. So we want a 12.3. Let's go with 60 there. Minus 12.3 millimeters here, and 58.005. We leave it a 5/1000th of an inch margin in between them. And then we're going to go minus 13.9 millimeters on this point with 59. So that's actually a good shape for the threads. And there's one thing that I should have done differently on this. And that is I want to actually extend this. Hold on a second. Oops. I want this shape, this helix, I'm sorry, this circle on top to be 12.3 instead of 12.2. I like to see how the thread touches the edge of the helix now. And I like to do that because you don't want things to fit together 100%. You need to give them a little bit of space, a little bit of margin. And so now, of course, all we're going to do is we're going to do a swept cut. And we're going to cut that triangle shape along this spiral. And what we've done there is we have now created a female thread pattern. And if I change the view here, you can kind of see it in 3D a little. Oh. There's something that we forgot, that I forgot. I'll show you that. On our revolve sketch, this point is in too tight. We need to take that out to minus 12.3. That was actually covering up our threads. And we need to do the same here. Minus 12.3. Now that we do that, you will be able to actually see the threads. And there you go. So, there you go. That's what the threads look like. Now, you notice that the threads are the cut doesn't go well. It kind of cuts into this this revolved shape that we made there. That's not good, right? So we simply edit that shape, and the way we can do that is, well, let's see what's the easiest way to do that. Simplest way is to just give yourself another line out this direction and attach that on the same point, and then trim out the line that you don't want. And so what you have at this point is you've got, oops, apparently I have a, oh, I didn't, the trim didn't work. Let's try it again. There, trim it. Okay. And there you go. So now you've got your shape and you don't have that problem. And if you wanted to, you could even, well, actually let me zoom out to show you this. It's kind of cool. You can look underneath it and you can see the threads up there inside it, and you can see the lower threads as well. Now if you want to on this, you can even do a photo view add-in, and you can do an integrated preview render of exactly what we're seeing. So it's going to actually do a photorealistic render at this point to show us what this piece would look like, even as we're doing our designs. And it's pretty cool because you can rotate it around and it's going to give you a photorealistic look at your part. And the pixelation you see is here. It's not in the video. It's actually, because it's rendering this in real time, at first it's strongly pixelated, and then it increases the resolution as it calculates it. And I can actually work with the piece using this integrated preview. And there are the threads that we built. Now this piece will allow you to attach a garden hose here, and then the bottom will attach onto a mason jar. I'm not sure why you'd want to do that, but if you did, you could do it. And then you take this piece, you just print it out on your 3D printer, and you're done. You've got your piece. So this is some of what I am doing as I'm designing all these various inventions that are going to be released on foodrising.org. Let me go back to the regular view. These are some of the geometries that I'm working with. One of the things you'll notice here, you see this angle? In a 3D printing environment, you can't print an overhang angle that is more than 45 degrees. For example, you could not, I'll show you a quick example. Oops. Let me try something different. You could not have a shape such as this. I'll draw you a sample shape. You could not have a shape like this and expect it to print if you extrude it. This will not print because this overhang here means the printer would be trying to print in the air, and it can't print in mid-air. So you can't have an angle like this. Even if you try to do a revolve base with it, let's say. Let's give it an axis here. It doesn't like the axis selection. Let me edit the sketch. Put in a center line. It's not even in the center exactly, but good enough for this demonstration. If we were to take this shape, there we go. And if we were to do a revolved extrusion, and you can see it better from underneath, that shape will not print. So when you are dealing with the geometries of 3D objects in a 3D printing context, there are things you can do and there are things you cannot do. And one of them that you can't do is this. So this is a very strict and critical limitation that you need to understand if you are hoping to design objects for 3D printing. So actually let me remove that extrusion, and in fact I'm gonna extrude it a different direction. Show you even like this, even if you just do a standalone block like that, that won't print either. So there is a reason why I use this cone shape here, which has roughly a 45-degree angle. That is printable. But many things that you first imagine are not printable. Another example of that is you can't turn this entire object on its side and expect, in fact, let me show you that. You can't turn this object on its side and expect to print this. If the shadow is your base, you won't be able to print this shape, because what you have here is you have a negative space cylinder parallel to the x-axis, and 3D printers cannot print those shapes with any kind of accuracy. They can do them when they're very, very small, such as 1 millimeter or a couple of millimeters, but to print a large cylinder, such as this entire cylinder here, to print this standing on its edge like that, it's impossible. It won't print. You get a big mess on your printer. So obviously you don't want to do that. You need to print from the z-axis and understand the strengths and limitations of 3D printing when you're designing the geometry for practical items, such as the ones I'll be releasing on Food Rising. So check it all out on foodrising.org. This is where we will have the inventions released. It's all a non-profit effort, and you can see some of the company's technologies that we're working with. We use Agilent laboratory instrumentation. We use flash forward printers right now, Solidworks software, and we're sharing many of these via open source. So check it out at foodrising.org. Subscribe to the email if you'd like to be alerted when we announce these really revolutionary objects that you'll be able to use in a practical context in your own life to create abundance and enhance the quality of your life. Thanks for listening. This is Mike Adams, the Health Ranger of foodrising.org.